Hi everyone, it's Ms. Chow, and today we are going to cover section 5.3, which is multiplying polynomials. And we're going to start by talking about multiplying monomials. So what's a monomial? Well, a monomial is an expression that contains just one term. So for instance, 4x to the sixth, that's a monomial. Just write it up here because it has just one term. Or 5x, that's also a monomial. Or even the constant 2, that's a monomial. You could say it's 2x to the 0. And then if we think about binomials, just to have a refresher, a binomial is a polynomial with two terms. So 3x minus 2 has two terms, 1, 2, so it's a binomial. Or 5x plus 3, that's also a binomial. And finally, a trinomial is an expression that contains three terms. So 4x squared plus 2x plus 6 is a trinomial because it has 1, 2, 3 terms. And then if we were to say, okay, what's the degree of this trinomial? Well, the degree of this term is 2 because it's x squared is to the power of 2. And the degree of this term is x to the first, so it's 1. And this term is 0. So the degree of this polynomial is 2 because that's the highest degree. Okay, in this next section, where the question says name these, so these polynomials, and state the degree. And I just want to remind you that the degree of a polynomial in one variable, so one variable means like only x in the polynomial, or only y, or only z. So the degree of that polynomial in one variable is the degree of the largest exponent in a variable. So in this case, it says name these. So what is this one? What is this one that has only one term? Well, up here it says it's a monomial. So this is a monomial. And the degree of the monomial is the degree of the largest exponent. So here the exponent is 1, because x to the first is 1, so the degree is 1. Okay, in this case, 4x plus 2, well, how many terms are there? There's 2 terms, right? So if it's 2 terms, then it's called a binomial. And the degree, so I'll write down binomial first, binomial. And the degree is the degree of the largest exponent in one variable. So the largest exponent here is a 1 because it's x to the first. So the degree is 1. And then in this case, is this a monomial? Well, no, because it's got 2 terms, 1, 2. And so it's also a binomial because it's got 2 terms. And then the degree, well, the degree of the largest exponent. So here we have, on this side, we have 2. And on this side, well, this is x to the 0. So this is 0. So your degree is the largest exponent, so the degree is 2. Okay. And I want to just go over again the definition of polynomial, because there was a question about it yesterday. It said, what is a polynomial? And I think it's because it's just this series of terms. And so it's odd because there's no equal sign in it. There's no there's no equating or inequating or anything else. It's just a sum of monomials. So there, up here we know 3x is a monomial. It's just a sum of monomials where each monomial is the sum and or difference of terms. So that just means that it's a bunch of terms put together, added or subtracted, and that gives you a polynomial. So I don't know if that helps anymore, but it is just to say that each of these, if they were alone, they would be considered monomials. But put together and separated by an addition or subtraction sign, that makes them polynomials, or many names or many terms. So in this case, then, let's look at this a little bit more. So degree of polynomials in two variables. So that's if you have x and y, or you have a and b. So your polynomial doesn't just have x like these had up here. It also has another variable, which is maybe a y or an a and a b. So polynomials in two variables they consist of this form. So this number out here, a, could be anything. So let's erase that because we're talking about a as a constant here. So it's a, x to the n, y to the m. Well, why am I telling you this? Because some polynomials have two variables. Some have three variables, some have one variable. And things like indicators like x and y, they are each variables. So if you have, I'm telling you that a, x to the n, y to the m, so 3 x to the first, y to the first. If you're looking to find the degree, and we talked about this a little bit yesterday, you would add the exponents. So for this particular term, which is a monomial, you add x to the first and y to the first. So you add the 1 and the 1, and that gives you 2. And that is the degree of that monomial. So let's try this one down here. It says simplified 2xy squared minus 3x squared y plus 8xy squared minus 2x squared y. Well, I'm going to erase this here. What happened? And put some different colors here. So we have 2xy squared. So do we have any other terms that are xy squared? This is an x squared y, that doesn't count. Xy squared. So this is another term like that. And this is not. And then if we had, now we have 3x squared y. That's a term. And minus 2x squared y. So that's also a term that matches that term. So if we want to simplify them, we have to combine like terms. Okay? So xy squared and xy squared. Well, those two are like terms. So we have 2xy squared plus 8xy squared. And then, I want to use red. And then if we looked at the next one, well, it's 3 minus 3, I'm going to put it over here, minus 3x squared y. And then this one is also x squared y, so minus 2x squared y. And I'm going to just get rid of this for right now. So then, if you want to combine the terms, well then these two terms combine to minus 5x squared y. And these two combine to, let's see, 2 plus 8, so that's 10xy squared. So then if you were to write out this equation, you would have 10xy squared minus 5x squared y. So that's the simplified version. Now, what if I said, what's the degree of this polynomial? Which is actually what? What is it? It's not a polynomial, but it's got 2, so it's a binomial, right? And so then what is the degree of this? Well, the degree is this, let's see, if x to the first and y to the second, so the degree of this term is 1 plus 2, or 3. And the degree of this term was x squared y to the first, so again it's 1 plus 2 equals 3. So the degree of this polynomial, because these two are equal, it doesn't matter, so the degree equals 3. Okay, we will do more. Okay, but that just sort of gets you started to thinking, why yesterday was I adding the exponents, and what does that really mean? Well, when you have two variables, you have to add the exponents to figure out the degree. Okay. So then I just want to go through real quickly here the exponent laws, because they will help out now. Remember when we had x to the n times x to the m, that equaled x to the n plus m, right? So if you had 3 cubed times 3 to the first, well, that would equal 3 to the 3 plus 1. And you could even try it out. So 3 times 3 is 9, times 3 is 27, times 3, which gives you 81. And that equals 3 to the fourth. So it works. Okay? And similarly, so that this is kind of what we're doing up here, right? This is what we're doing up here with our combining like terms and adding them together, and then coming up with the degree. So the degree is this plus this. So, and then if you have x to the m divided by x to the n, that equals x to the m minus n. Okay, so the top one minus the bottom one over the division sign, and then x to the n raised to the m gives you x to the n times m. Okay, so what we have here, let's go down to what today's lesson is, which is multiplying monomials and polynomials by other monomials. Multiply monomials by monomials. And some examples include, so monomial, like a single term times a single term. So what we want to do is multiply first the coefficients. So if we multiply the coefficients, well, the coefficient of this is 5, and the coefficient of negative x can be really, you could write that as negative 1 times x. So you have 5 times negative 1. I apologize, this is messy here. So I'm just going to write it over here. So negative x equals negative 1 times x. So if you're multiplying 5 times a negative 1, that gives you 5 times negative 1 times x times x. So those two x's. So that would equal negative 5 x squared. Okay. How about the next one? 3x times negative 2x. Well, you multiply the 3 times the 2, which gives you 6, times the negative 2, negative 6. And then that's times x, which is x squared. Equals negative 6x squared. Okay. Now, let's go down to this one here. Oh, two negatives. Okay, so you have negative 7 times negative 2. And you have x times y. Oh, that's interesting. X times y. Well, negative 7 times negative 2 is a positive 14 xy. Oh, I forgot to box this one up. Okay. So then the next one is, let's see, 6x to the 4th y squared times 3. Okay. So 6 times 3 is, I'll write it out here, 6 times 3. And then x to the 4th times x, right? No, go this one. X to the 4th times x. And then the last one is y squared times y squared. Okay, and that gives you 6 times 3 is 18. And then x to the 4th times x to the 1st. Well, if you remember our rules, first gives me x to the 4 plus 1. And y to the 2 plus 2. And that reduces to 18x to the 5th, y to the 4th. And then what's the degree of this? Well, the degree is, the highest power of x here is 5, and the highest power of y here is 4, and so the degree is 9. Okay, and you can apply this also to multiplying by binomials, so monomials by binomials. So if we have 5x, which is a monomial, times 2x plus 3, which is a binomial, that would be, well, you do each term. So you do 5x times 2x. So it's 5x times 2x plus 5x times 3. And so that's 10x. 5 times 2 is 10, so you're multiplying your monomials. X times x is x squared, plus 5 times 3 is 15, and that x. So to multiply 5x times 2x plus 3, you just simply multiply the 5x by each term, so 5x times 2x plus 5x times 3, and add them together, and that's your result. Okay, and one more here. Let's see. 8x times 2x minus 3. Well, so what do you do with that? I'm actually going to bring you over here because I've run out of room there. Okay. So you have 8x times 2x. 8x times 2x. Minus, keep the sign, 8x times 3x. Okay, so 8x times 2x is 8 times 2 is 16. And then x times x is x squared. Minus 8 times 3 is 24. And x times x is x squared. And so actually you can combine these two terms and make a single term because they have the same variable and exponent. So this would be minus 8x squared. And that's the answer. Reduced. Okay. Multiplying monomials by polynomials. All right, I'm going to have to give myself a little bit more room for this. Takes up a lot of space. Times minus 7x squared minus 3xy plus 7y. Okay. And just like we distributed above here in a binomial, we're going to distribute here in a polynomial the same exact way. So we would have 4x minus 7x squared minus, you see the minus sign in there through all my lines? Okay, there's the minus sign. So minus, and then this one is a plus over here, so but we're just starting with the minus. Minus 7x squared minus 3xy times 4x minus 4x times 3xy and then plus, because it's a plus sign, 4x times 7y. So what do we have here? We have 4 times negative 7, which is negative 28 x cubed. And this is minus 4 times 3 is 12. And that would be x times x is x squared. And x times y is xy. No, I'm sorry. X squared y. I was just thinking, you can see here, so this is x to the first and x to the first. So if you used your formula, you'd say x to the first times x to the first is x to the first plus first. So 1 plus 1, which is 2. So that's what that gets right there. And then here we have 28, which is 4 times 7 is 28. And then xy. And I think that's reduced because there are no like terms. There's no other x squared y, there's no other x cubed, and there's no other xy. So that's your final answer. Okay, and down here I have, I'm going to do the same thing. Map each one against the next. So it's minus 2q squared times minus 4p squared q. Okay, and minus 2q squared times 3pq. So that's minus 2q squared minus, oh, pardon me, it's not, it's positive 3pq, or minus 3pq, but I put the minus sign out here. And then minus again, minus 2q squared, and 3q squared. Okay. So what do we have here? We have minus 2 times minus 4, which is 8. We have 8. We have p squared. We have q squared times q, which is q cubed. Do you understand how q squared times q, well, that you can assume a 1 there, so that equals q to the 2 plus 1. Oops, 2 plus 1, sorry. Okay, 2 plus 1, and that equals 3. So that equals q to the 3. So that's how I get q squared times q is q to the third. And then this actually is a minus times a minus, so that's a plus. And so 2 times 3 is 6, because you multiply the constants. Then q squared times q is like this here, so it's q cubed, and p, just one p. And finally, over here, 2 times 3 is 6, but it's negative and a negative, so that's plus 6 again. And q squared times q squared. Well, q squared plus, it would be plus 2. It would be q squared times q squared equals q, 2 plus 2, which equals 2q to the fourth. Now again, we don't have any like terms here. It's p squared q cubed, but it's just a p, and q to the fourth. Now if I asked you the degree, what's the degree going to be? Well, the degree you figure out by adding the exponents. It's multivariable. So this is 5, and this is 3 plus 1 is 4, and this is 4. So the degree is 5. Good. Okay, let's move on. Now, here's the fun way to use these. You can apply them in word problem settings, and that makes it more interesting. So it says, write an expression for the area of a bedroom rug if the dimensions are 3x by 2 by 5x. And so I put it on the picture for you here. So here's one side is 5x, one side is 3x plus 2. So how do you write that as an expression? Well, and we want the area. So area equals base times height, right? Area of a rectangle. So that equals 3x plus 2 times the height, which is 5x. So if we multiply, if we take our and distribute, we take our numbers and distribute them, 5x times 3x and 5x times 2, we have 5x times 3x is 15x squared, and 5x times 2 is plus 10x. So this is the equation, or an expression. It's not an equation. It's an expression for the area of the rug in the bedroom. And then in the next piece of information I ask for is, what is the area if x equals 2? Okay, well, if x equals 2, then you would just put that into the equation. So you would have 15x squared plus 10x is 15 times 2 squared plus 10 times 2, and that equals, well, 15 times 4 is 60, and 10 times 2 is 20, centimeters squared is the area. Area equals base times height, so it equals 15x squared plus 10x, and then it equals 80 centimeters squared. So that's the size of the rug. I have more examples that I would like to show you, but this video is already 30 minutes long, and I think that anyone's capacity to sit still for much longer is really limited. So I would like for you to go out and have breath, and then I will distribute another video that has more examples of area, surface area, those kinds of things, how to calculate those using polynomials. So, and then we also have a bunch of examples in the book too, but I wanted to provide you some here just so you had something to follow. So I am going to sign off now, and I will send a follow-up video with just examples of surface area, perimeter, area, those kinds of things. All right, have a great day. Thank you.